Good morning, everyone. So welcome to today's webinar. So I'm happy to have today's webinar with my colleague and my friend Ken, our chief architect today, to share about the Timeplus Proton 3.0. So the how we in our latest release, how we connecting the operational and telemetry systems. So before start, let's have some housekeeping items. The webinar will be recorded, so feel free to share the recording. We'll share the recording link. And if you have any question about today's webinar, feel free to submit them in the chat. And we have a Slack channel, so please join the discussion or ask any question about Timeplus or Proton. So yeah, this is the one of the quote from our customer. They say Timeplus is the missing piece between operational databases and telemetry system. Actually, it's not only the optional database, it's actually your any of your operational system, like your ERP, your application, your application database. So all these are generating your critical data for your daily operation. And there's a telemetry system like observability or analytics system. So uh, Timepass can help our customer to effectively moving data and processing data between these two systems. So yeah, that is the also quite a lot of feedback from our customers that the key issues, key problems Timepass are solving today. So today, I'm going to share about the Timeplus Proton because we recently released 3.0. So the Proton is actually the core engine of Timeplus, and it's a single binary data processing pipeline for any like analytics, observabilities, or security use cases. So, so for all the Timeplus and enterprise actually is running on this Proton, this key engine. It's actually we did open source it in like 2 years ago, and recently we actually released Proton 3.0. So today I'm very happy to share about this exciting release. So the Portal is actually written in pure C++, no JVM, no ZooKeeper. So there's no any dependency. So with this single binary, it can do anything. And here's the architecture. If you want to know more, please visit our website. So yeah, here are some highlights about Proton 3.0. So it is the most significant release we have to enable our customers and users to build data processing pipeline for like observability, security, and analytic use cases, right? Here's some thing I want to share for the performance. You can see we have quite a lot of performance improvement, like ingest 2 times faster, aggregation 7 times improvement, Java UDF 2 times improvement, and also like a hybrid join with like 10 times more memory efficient. For the functional wise, you see, we do in this release, we actually released most features. Uh, there's like alerts, task, Python UDF, dictionary direct join, and a lot of like a downstream, upstream integrations. For example, Iceberger, i3, MySQL, Postgres, MongoDB, and very important is for your observability pipeline. You have Splunk, Elastic, and Datadog integration. That means it's more easy for the Proton users to process your observability data, right? So, and today I'm also going to make a demo about this, a real observability pipeline use case leveraging these features. Last but not least, also there are a lot of improvement about observability. So you can monitor your data processing pipelines for all the different metrics like CPU memories, EPS, or the whole system, right? So There are a lot of metrics. You have two ways to monitor these metrics. Either you can just run the SQL from the system table provided or system stream provided by Proton, or all these metrics is exposed as Prometheus metrics. So you can either use your Grafana dashboard to monitor everything. Okay, so next, I'm going to make a demo about using leverage these new features. So one of the demo I'm going to share is the Cisco ASA firewall logs. So how we leverage Timeplus Proton to process this our observability data pipeline. So here are some background about this demo. So one of our customers is monitor their Cisco ASA firewall logs. So based on my experience working at Splunk back days when I work at Splunk, so actually Splunk has very good product and Splunk customer really loves this product, right? It's super easy to use, super powerful. But when I ask our customers, say, hey, any other feedbacks about the Splunk? The customers say, hey, no, it's good. Everything's good. But the only only thing they don't like is Splunk is kind of expensive, right? So that happens with all the observability system like Datadog or Splunk, because they're usually you have large volume data, large volume of logs, events, and usually it costs customer a very huge expensive expenses, right? So one of the issue I'm going to share is actually leverage this data processing pipeline, right? You can reduce the noise, so reduce the duplicated data, reduce the noise, and only keep the critical data. And also the first thing I'm going to share is also you don't have to wait all the data sending to downstream observabilities when you have some critical alerts, right? Security issue you want to identify. Because when all this data sent to downstream observability system, usually it will experience like indexing or search quite a lot of logs that may take a lot of time, right? So there are two things I'm going to share with the Timeplus Proton pipeline. So one is noise reduction. So we leverage like sampling, filtering, uh, to dedupe to reduce the data size and only reduce the noise and only keep the critical signal. So you only handle so by doing so we save a lot of storage or processing expense. And this is the pipeline I'm going to share here, like this. And the other thing I'm going to share is about the real-time alert. By enrich all these datas, we actually can do a alert. So that means as soon as something happens, before sending all your data to downstream observability system, you can already uh, doing this alert as soon as some security issue happens. So I'm going to show that as well. So yeah, this is the Timeplus Proton data lineage UI. So you can see I already created data processing pipelines. So I'm going to show you the details of this pipeline, what it does. First, let's go in to this part of the noise reduction features. So first, we have all the data here. Is the Timeplus external stream, so that all the data actually came from Kafka topic. See here, we query this stream. You see, it give you the ASA Cisco ASA logs. So the raw logs look like this. What I'm going to do is actually just um, we parse the MV. We have a MV to parse the log, turn the log from the JSON, the unstructured data, to structured data. So like we extract all the fields from according the syslog format, right? All the all the ASA logs actually is actually syslog. So we extract priorities, timestamp, device name, and some of this key information that's shared among all the ASA logs. Let me talk about this materials view. So materials view is actually the key component of Timeplus Proton. So it keep processing your data in an incremental. So if you take a look at the result from the materials view output of this, so we actually get this structured data. So it's no longer the unstructured log. We get all the fields like the device name, severity, message ID, and the message. Still, the message is still unstructured logs, but we already got all the common fields in this case. Okay, let's go back to the lineage. And actually, what we do here is I have some views. So do the sampling, filtering, and dedupe, right? So that's the way how we remove those noise. Because some of the noise, some of the logs are just for example, this sampling case, we actually uh only keep some high severity issues, and for the other part of logs, we actually keep a sample like 1%. We keep 1% of the non-severe issues. So by doing so, we do some filtering, we do some sampling, right? Uh, and then we do some filtering here. So we only for filtering, you can say, hey, I only want to keep specific messages according to the ID, right? Or you can just say for these kind of message ID, I don't care because they're not important, right? We can just filter them out. So that's the filtering, right? It's a simple CQ. And now the dedupe, right? So for the dedupe, it's actually a stateful operation here. So we actually dedupe based on we do some extraction. We extract like source IP and destination IP, and we do the dedupe based on the past like 5 minutes window. So we only keep the non duplicated source IP, and based on this information, so we can dedupe a lot of redundant messages, right? Okay, so by doing so, we actually the last one in this pipeline, we actually do some routing. The routing is also simple. We just based on a different message type or some other conditions, we give it a label, right? A tag. So for the different, for example, for this high severity issues, we actually say, hey, we want to send this data, this event to Splunk, right? So do some security analysis. And for this kind of issue, we want to send to some other destinations and so we tag different event to different destinations. So uh, let's take a look at this step. You can see if we query this view, we actually get some filtered, deduped results. So the data has already been reduced, only keep the key signals. And also we add this destination label. So in the next step, we will send different event to different destinations. Let's go back to the lineage part again. So you see we have two MVs. One just read the destination for some of the data we send to non-relevant, non-important, or some audit logs. We want to keep a history, we send to S3. And for the key high severity issues, we send to Splunk, so Splunk can do the search. So you see, and you can see with this materials view, we do the data input throughput is like 16K and output is only 600 bytes. So that means we greatly reduce the data volume. So you only keep the key data to Splunk, right? So the other part of the data we send to like I3, so to keep all the history. So you don't need to worry about so actually you can still keep the low value data there. Okay, that's the noise reduction pipeline. So the other part of this logs, I want to show we want to do a real-time alert. So for example, some critical issue happens or there's some security attack, brutal force attack or DDoS attack. So we can do this kind of monitoring in real time by the new feature of alert. Okay, so this pipeline is also we start with the parse the log. So what we do is actually you can see we parse the data using a group pattern based on the different message ID because for ASA logs, so different ID has different patterns, but we actually can extract all the details of the information from different message patterns. So and then we do a flatten because the grok extraction generates a map. So what we do is actually we extract all the details information like direction, protocol, connection ID, and all this source port, source IP, something. We extract all the information into a big flattened table. So and then we use this MV to keep this flattened table into a target flattened log. Let's take a look at this flattened logs. So by this extraction, you can see we actually get all the extracted fields in the target stream. So it's a little bit slow. Let's wait. So it should give us the logs. Maybe there's some latency. Let's wait. I'll go back to the lineage. I don't know why it's not happening. Anyway, so based on this flattened logs, we actually have all the views of all the alerts. For example, we create a view to query whether the severity is 1, then it's a critical issue. We want to take response as soon as possible. And also if there's a brutal force attack, that means actually for some specific message type like it's authentication issues, well in a window in a tumble window like 1 minute window, if there's repetitive authentication failure issues in this case, and there are more than 30 authentication failure in a 1 minute window, then that's a brutal force attack, right? So similarly, these are the stateful processor. You have to leverage some stateful data processing technology to get this information. And the others is DDoS attack. You see, let's go back. The DDoS attack. If you take a look at this DDoS, so it's actually similar. Actually, one of our customers is using the similar technology to do the DDoS attack. So in this query, we actually say, hey, if in a 30-second hopping window every 50 seconds, so we will count if there are events from the same the event sent to the same destination IPs. There are more than 100 events, and from 10 different source IP. We believe there are some DDoS attack happening, so we want to take action as soon as it happens, right? So these are the alerts we have, and so eventually we have an alert, Timeplus alerts. This I can take. Let's take, and any of this event happens, I have a view to get all this information, and any of these alerts happens, we will trigger alert. So Timeplus alert, you can take a look, we create this alert. So, and generally this alert will monitor these queries. And once something happening, we call this UDF to send the alert to the downstream system. In this case, we have this alert UTF. So this is a simple alert UDF, Python based. So we just post something of the alert information to the downstream system. For them, in this case, I actually already I have a background materials view that generated data. So you can see if I the MV is paused, I can show you the data simulation here. So you can see actually I'm using this simulator to generate data and send data to Kafka, right? So all the alert I am pausing it's actually data even generated by this random stream and send data to Kafka. All this so I'm currently sending normal logs, but I can simulate like a brute force attack or DDoS attack or critical event. If I unpause this MV will move data from this random stream to the Kafka, right? So let's resume, right? Okay. Okay. You see, once I resume this matters view, the event generated, and as soon as the event generated, this downstream alert system get notified, right? Um, this is a very sophisticated pipeline processing a lot of data, but you can see there's even no second delay, right? Any once the event generate, as soon as it's generated, there's the alert was triggered without any delay. What Timeplus Proton provides is actually like this pipeline data processing system. It can help you filtering, dedupe, routing, or enrich your data. And also it has the in-pipeline alerts. You don't have to wait. So for this filtering, it can help you save your cost. You don't have to save all the low value data to your downstream system. And also with this in-pipeline alert, you actually can fast response to your critical security issues without waiting, right? You don't have to wait data to be indexed, to be searched. You can take action as soon as possible, right? And all these features you can see actually is implemented in Timeplus SQL. So and the performance is super good. Yeah. Okay. So that's the first demo that covers most of the uh, Timeplus Proton new features. And another demo I'm going to share is we also have another new feature called Task. So Task is just something like a scheduler or cron job. So it repeatedly running a SQL query. And in this case, I actually show you how we can leverage this task to get data into Timeplus, right? So, because Timeplus already has a lot of source and sink capabilities, like leverage the external stream or external tables. But not all the external stream are streaming. For example, in this case, I want to just grab data from Hacker News, right? So in this case, I leverage this task and it's run like every 30 second or something. And it will run the SQL query, and this query will trigger this UDF and grab some data from Hacker News using the Hacker News HTTP API and get data return. And then all this task is actually will writing all the query output into a stream. And this stream now contains all the real-time data from Hacker News. Also, we have check this in this query, we have a checkpoint mechanism to know which Hacker News mask Hacker News ID we already grabbed. So we will next time we will grab from the latest ID, right? In this case, you can see we have a data lineage. So we have a stream called Hacker News Post, and we have a task that keep grabbing data from Hacker News. And we can take a look at this task design. So task. Yeah, you can see we have this task called get hacker news. And if you take a look at this details, you see we actually have a scheduler every 10 seconds. We actually run first. This is actually checkpoint. We get the max post ID we already have here. And then we actually call this query to keep grabbing a post from Hacker News, and the result we will save to the Hacker News post. So, and this is the UDF we use to grab data from Hacker News. So I want to show you the data here. So if we run this query, say from Hacker News in the past 1 minute, you can see these are the data we grabbed from Hacker News in the past 1 minute. So the latest story, you can see it's actually real time, right? So the new comments is coming. So the latest story is this like call, oh, this was, you can see there's no title. Um, but this story, how to use trending topics. So we check, let's see what happening. You see, this is how to use trending topic is the latest story, and it's actually exactly what we grabbed here. So this is actually a silent story. You can see there's no title. So so by doing this, we actually can grab data from any data source, leverage this Python UDF, because Python is super powerful. It can do it can almost do anything, right? So next, I'm going to share something about the the engineering story because due to the time limitation, I just quickly highlight something happening with Proton 3. I do have a lot of blocks. Recent for example, the hybrid hash join. So it's solving the problem like all the stream processing are facing, like the if you join to stream, you need to keep the state of both sides. And for high coordinate data, this state can be grown very, very big. So what we do, traditionally, the data processor keep them in either in memory or use some background state. But with Timeplus, we use this hybrid mode, right? The most important state or most visited state, we keep in memory, and we keep all the other state in a disk. That by doing that, we actually can have a very good balance and very good performance. I have a blog talking about this. Please visit our blogs. And next, about the MV resilience, as I mentioned, the materials view is actually will view my pipeline, right? So materials view is the most important concept in Timeplus. So originally, the materials view is just something like a simple background job that keep reading your data, writing your data, right? But with more and more customer using Proton and Timeplus, we got a lot of feedbacks about how we can improve the materials view. So you can see, so materials view is actually not just a simple query, it's actually a full service, right? So so in Proton 3, we actually materials view has grown into a from a query that running background into a production service, right? We have lifecycle management. You can see how different lifecycle, how the state machine that transition the state of the MV from different state, and we have a different recovery service. What happens if something bad happens? How to recover the materials view? How to keep the durability guarantee? And also a lot of observability, like how you can observe what's happening with the MV, right? So that's all what we provided in Proton 3. Also, we have a checkpoint, like a checkpoint is one of the important concept in stream processor. It keep your state, your joining state, your query state, right? So we have a lot of improvement in the checkpoint as well, like incremental RockDB based background checkpoint. Also, like different workload, we should have different checkpoint mechanism and the interval, how we provide a flexible interval for about when to do the checkpoint and how to do the asynchronous checkpoint mechanism. And we also aware that for different storage, like the streaming data and historical data, we want to keep them in different different storage. Yeah. I also have a blog recently released talking about the checkpoint, and please read it. So this is a detailed checkpoint design. It's covered in a blog, so I'm not going to talk about in detail today. So last, also about Python UDF, I believe this is one of the most exciting feature we have, because with Python UDF you can do and lots of stuff like get different data like I show in the Hacker News demo, or you can do some machine learning or AI jobs with leverage Python UDF. So, but there are a lot of challenge we solved in this release, like uh, how we can have different data representations for Proton, C++, for Python and NumPy, and also how to manage dependency, how we just run PIP. We actually turned PIP into a system command using SQL. Also the integration with Cyson, there's like because the how we make these two different processor working together, or how to do the security isolations. So I'm going to release a blog talking about Python UDF, which is also a lot of technical details we want to share with our community users. So yeah, please take a look at the Timeplus blogs about all these things happening. Yeah. Okay. Next, I'm going to hand over to Ken, our chief architect. He will make some introduction about Proton, and yeah, Ken,
Yeah,
your
thank you, Gang. Yeah, so we have quite a few slides for the 3.0 updates. Since it is a very big upgrade and lots of functionality or as well as performance enhancement. So let's go through these slides real quick. Next slide, Gang. Yeah, so there are several sections I like to highlight. Number one is the core engine enhancement. So what's powered Timeplus Proton, and then some of the core features in Timeplus Proton as well. The last but not least, is observability enhancement in 3.0, which is super important for our developer to build and also management the pipeline in production. Next one. Yeah, Timeplus, in general, we are using the streaming SQL. The streaming SQL is basically has vectorization and also JIT enabled, which is super fast. So from this example, you can see we can use one SQL to do the join and to the tumble window and then to the join and aggregation. And also we can bake in the Python UDF, JavaScript UDF. Yeah, everything is driven by SQL, and user basically using SQL to using SQL to build the pipeline, and also we extend the streaming SQL a lot with the streaming semantic. Like we have quite a lot of different emit strategy for different kind of use cases. Next one. So yeah, here's the Proton architecture. So I think the online one could be very interesting, which is a native log. We call it the wall. The native log is basically acting like a persistent queue, back pressure, data queue, and also notification workflow. And the native log is basically queryable from user can basically when you user run a streaming query, SQL query, basically the SQL query read the data from the native log directly. So native log is a building block in the whole Timeplus Proton because when you do the data processing pipeline, when data ingestion to Timeplus or either push to Timeplus or pull to Timeplus pull the data from different external data sources, we will use native log as the persistent queue to buffer, the ingest and the high peak of the traffic, and also enable streaming query processing. On top of that, we have different storage engine we call it. One of them is the version KV, which provide the mutable semantic, and also append stream, which is immutable semantic. Append stream is basically encoded by using columnized format, and the the version KB, others is using the row-based encoding, which is super fast for the data mutation, as well as the lookup point lookup performance. And also in the query processing layer is we have the single query processing engine for streaming and yeah, you can do historical query as well. Historical query basically enrich the whole data processing pipeline. For example, if you like to compare the real-time data with the historical data or correlate this between these two data, you can use in one single query to do that. And as Gang mentioned, we have JavaScript and Python extension. Mostly importantly, on top of that, we have different data source integration like vector-based and MySQL, Postgres, Apache Iceberg for data source and data sync. So user basically can use the Timeplus as a single data processing pipeline engine to move the data from source and do the very rich in processing like transformation, join and aggregation, and sending the data to the downstream. Next slide. Yeah, so the key principle in one of the key principle in Timeplus Proton is we call dual store and dual query. Native block is the stream store we call it, and buffer the data, and it's just like a persistent queue, but queryable. And in the background, we have the historic data store append stream, and also the mutable stream or version KB stream, and they can use it to enrich the whole data processing pipeline. Next one. Yep. So let's recap a little bit. So with this is the key technology powering the whole pipeline. One is the storage, stream store, and also historic data store. And with in Timeplus Proton, we support the streaming query, historic query as well. Next one. So here's a list of key features. So Timeplus Proton support, I think from functionality point of view, we support the most of the streaming query processing semantic for sure. Either the join and aggregation or also windowing. If user like to, and Timeplus Proton has built-in like more than 1,000 built-in function, native function written in C++, as well as more than 300 aggregation function. For the join, we support different kind of mode, like hybrid Hashi join, if the join cardinality is super high. Aggregation as well. We support pure in-memory aggregation and also hybrid aggregation to honor the high cardinality aggregation use cases. And join is super rich. We support different join semantic like a bi-direction join, direct enrichment join, and also some of the changelog join as well for the data mutation semantic. Next one. Yeah, for the system extension, so sometimes use cases the use case is super stateful, like state machine, processing or CEP sometimes, which is very stateful, or there's a state transition, and using this pure SQL is really hard to maintain. It's really hard to write to implement, and the user can use the JavaScript or Python script to do the extension, create Python UDF or Python UDAF, and which is super convenient, and sometimes is a very complementary to the existing native functions. Next one. Yeah, here's some of the signatures of the aggregation function. Since that we are short of time, so we probably don't have much time to delve into the details. If you are interested in the implement how to implement a JavaScript UDF or JavaScript Python script UDF, we have the detailed documentation to cover that. Next one. Yeah, Python UDF, same things, very similar. Next one. Yeah, schedule task, Gang already covered that. By the way, so one thing to highlight that schedule task can run a SQL, can basically run a SQL in a periodic way and run the SQL, and the SQL can have Python UDF, and the Python UDF can do anything basically because it has I/O. And it can also run a SQL to query the external system like Postgres, MySQL to move the data from the upstream analytic transaction database to Timeplus and to do the processing. The task is basically periodically running and then sending the output of the task to the downstream. Next one. Alert. Gang already covered that already. So we can call the Python script to interact with external system. For example, interact with the Slack, with the email, with any kind of alerting system, which is a superpower. Next one. Materialized view. Yeah, so materialized is basically the single most important entity in Timeplus Proton. It's basically glue everything together, running in background, doing the processing data from the source to the ET transformation, join aggregation, and sending the data to the downstream. The downstream can be a time process as well. So user like, yeah, I don't want to move the data. I have a small amount of data. I don't want to move the data to any kind of external system. They can keep the data in Timeplus Proton as well, using Timeplus Proton as a serving layer. That is doable. And also the material that has the checkpointing, it can recover from the checkpoint if there's something wrong with the whole environment or box. Yeah. Next one. If we glue everything together, so Timeplus Proton is basically all of the feature introduced in Timeplus Proton. We are enabling the end user to build the data processing pipeline in one single place, and we have built-in source and sink, and also we have task, we have alerts, and they can also use the Timeplus pipeline to interact with other systems. For example, we can do the interact with other system or the historic data as well. So, for example, we can store some of the because we have dual storage, so they can keep around some of the historic data in Timeplus Proton, and they can do the correlation with the real-time plus pipeline. And they can do remote interact with external system as well. For example, if they like using the pipeline real-time data to directly join the remote system like MySQL, Postgres, or MongoDB, yeah, that is possible in Timeplus. Next one. Yeah, last but not least, the observability is one of the from my perspective is one of the most significant improvements because when in production, our developer really needs to know what's wrong with the pipeline. For example, what's the CPU utilization, memory utilization, disk utilization for the pipeline. I need to monitor that in real time. If some of the pipeline has an issue, I can pause the pipeline, I can resume the pipeline, I can rewind the pipeline, for example. And also regarding the data processing event per second, throughput like a byte per second, and also total processing bytes of the whole pipeline DAG is also recorded in the system as well. So, and also if the pipeline runs into some of the issue, for example, the pipeline has aborted, and we will record the last error, the whole stack trace you can realize from the system, and also the last timestamp. System as well. So, for example, if you deploy Timeplus Proton in a one box, and I need to monitor the whole box CPU resource utilization, CPU memory, and disk. It is all over there in our system metrics table. There are three of them. The first one is introspection state log, which capture most of the recent metrics and states. And the stream state metrics log is basically the history of the materials view pipelines. And system cluster is basically the box, the node, the Timeplus node stats and metrics. Next one. Yeah, thank you. This is pretty much what we like to cover in 3.0. If you have any questions, join Timeplus community Slack channel, and also in the Timeplus Proton OSS, we have the GitHub repo there, and yeah, please give us a star as well in the GitHub. I saw, yeah, Fisher has some of the questions. Probably, yeah, we have time. We can still last maybe extend this a little
Yeah.
bit to cover Fisher's questions. So does the Proton also support Iceberg table read for change data ingest? So far, we do not support read the change data in Iceberg. So Timeplus goal is still like a pipeline, data processing pipeline, and it's based, Iceberg is most likely the sink. We can write a lot of data to Iceberg, but query back we have limit functionality as for now. But we have great a list of Iceberg enhancement in the pipeline because a lot of customer users have similar feedback like, oh, how can I do the partition right? How can I do the query processing against Iceberg table? And also, does Timeplus Proton support compaction? We have a great list of Iceberg enhancement ticket in the backlog, and we are handling that as well. Also, the next one. So based on the diagram, I'm interpreting bounded and non-bounded source doesn't matter. Task pull the data. Yes, exactly. Yes, exactly. Task can have checkpoint. It can pull the data based on the source definition. Yes, right. And another question based on diagram. Yep. So I think we cover most of them. If there's more, yeah, please join our Slack channel and raise questions there. We are happy to answer all of them, cover all of them there. Thank you so much.
Yeah. Thanks, Ken, and thanks everyone for joining today's webinar. Yeah. See you later.
Thank you. Thank you. Bye.